Hi. Today we're going to talk about Matplotlib. So what is Matplotlib? It is a library for visualization, mostly for the plotting, like a graph, bar graph, line graph. And so last week, because of the typhoon, we just list a bunch of videos that is about the Matplotlib, including a list to the repo of the code in this class. So you see like a few scripts of the Python notebook, and if you follow the notebook, you can learn or see something step by step to learn the Matplotlib. And also today we are going to present homework, our second homework. I will go to this shortly after I give a brief introduction to the Matplotlib. So I left all the coding details in the notebooks. So today I will not go into the details of the coding. In previous years, most of the time I will explain the notebooks in detail, step by step. But this year I'm going to change it a little bit to give you a more broad view of the field, about the tools that you are going to use. But you can still follow the notebook step by step and understand some details. So what is our homework? The homework is kind of like the first one. You are going to draw some images. Unlike NumPy, Matplotlib is more suited for doing the graphics. So in the homework one, we are using NumPy to construct an array. Then we use the pillow to actually render the image. However, in Matplotlib, we have a lot of tools for doing the for drawing images. Like you can draw circles. You can plot a curve. If you have a mathematical functions, you can plot a curve, and you can actually fill the color between two lines. That is something you can do. So the purpose of this homework is similar to the first one. By trying to accomplish a goal, like drawing an image that is in your mind, you are trying to find the tools, just like the NumPy. Matplotlib is a huge library. It contains a lot of different functionality. Some may argue it has too many functionalities. So it is kind of difficult for beginner to learn because you don't know how to start and how to find the tools. But by doing this homework, by trying to actually realize your creativities, you may want to find the right tools in order to just to realize your thought or your ideas. So for example, here are some examples of what you can do with these Matplotlib tools. because Matplotlib, you will see later, will introduce a lot of different libraries. Matplotlib is one of the more low-level libraries. So there are a lot of different tools you can choose from. So basically, you can one set of the tools of the Matplotlib is that you can use Matplotlib as a Illustrator, or like the Adobe Illustrator, or a editor of the vector graph. So this is this set of functionalities. So basically, you can describe this curve and plot these things on the screen. And also, you can do it more like functionality like a pillow. Because in this example, I'm using some ellipses or circles, mostly ellipses, because they are just circles with different axes, different lengths of axes. So I'm just using different circles here and plot some simple cartoon characters. So that's one of the things that you can do. So let me. Okay, and also in our notebooks, there's one example of the different matrix circles that you will see in detail. So that's also something you can do for your homework. In previous years, one of the homework is to use Matplotlib to draw a matrix circle, similar to this one, but more restricted topics. In this year, I'm going to loosen up the restriction, so you can choose any topics you want to do. But still, you can do the matrix circle if you want to. But you are not limited to do this only. In this example, we are primarily using the plot functionalities. You just plot some mathematical curves and using some filters. Filters are some kind of a special effect abilities in Matplotlib. Okay, so that's just a quick over preview of what homework is. So let's go back to our slides here. So when we talk about Matplotlib, usually we are talking about two different kind of things. The first one is the technical part. So what can Matplotlib do? Matplotlib can do a lot of different things for drawing image, drawing animations, or even doing 3D animations. So that's one aspect of the things we are talking about Matplotlib, the technical part, what it can do. We are mostly emphasis on this part, including our homework or throughout these slides. We mostly focusing on what Matplotlib can do. The other part is what we should use this to do the presentation. This really depends on what your goal is, because like the homework demonstrate, you can actually use Matplotlib to draw something like cartoon images or design image or something like a logo, a matrix circle like logos. You can do things like that. But most of the time, when we're talking about Matplotlib, or at least when you're doing computer science or data science or AI or machine learning, we are talking about we wish to plot a graph, informatic graph, to showing a line graph or a scatter graph, or maybe showing the decision boundary of a machine learning classifier, things like that. So this is more about presentations. How can we use a graph to deliver a concept or deliver the things that we wish to communicate with our audience? So that's another part about the presentations. That is also an important thing that we should discuss, how to visualize your data or things like that. But we are not, this is not our main primary topics or goals in this week. Because when we talk about pandas, when we talk about other topics like machine learning, we are still going to use Matplotlib. And we will cover some aspects about how and why you should use certain kind of graph to represent your data or represent your model. But this week we are mostly cover the or focus on the technical part, because if you don't know what you can do, your choices are very limited. So before we are going to talk about what kind of design choice about our graph or presentations. We are going to first survey about the technical details, or just an overview about how to learn the technical part. But on the other hand, in case you are not familiar about the scientific graph or plot things, you probably are less motivated. So the homework serves for this purpose, because even if you are not into or familiar with scientific graph or plotting, or like financial plottings in financial areas or other areas, you can still enjoy for drawing things, like drawing a cartoon character or drawing a picture, things like a mountain or flowers, things like that. So that is something people can share their feelings or experience. So imagine what you can do. Just imagine you are trying to drawing something on your computer using a Python code. It could be a scientific plot or a financial plot, like a stock curve, stock market curve, or maybe you just want to draw something like a cartoon character, anything. When you want to draw something, Matplotlib has the functionalities. So let's start with the introduction. This is the front page of the website of official website of Matplotlib. On the official website, you will see a graph on the near the left side, and this one is a slideshow. So we'll see it change time to time. So this is just one of the examples, and it will say that you can see a description of the Matplotlib. It is visualization with Python. Matplotlib is probably one of the most famous visualization libraries in Python. Maybe not. You may argue that it is not the best one, but still, it should be one of the library that people talk most about it. So the description of here is indicate what the author or the creator of Matplotlib think about the goal or what the Matplotlib is. And by the way, here is an interesting link. Let's try Matplotlib on Binder. Binder is a service that you can run a cloud machine freely. There are a lot of different cloud machines that you can use. Like if you are using GitHub, I think there's a GitHub code space, especially if you are a student. You can have like a student account. It will provide some use time for the GitHub code space. And there are some other like Colab. Most of them have some limitations. And Binder is another. But Binder is a service that you can basically run your notebook on it, or other service as well. Basically, one of the major primary use of Binder for me is running code from the GitHub repo. So you can set up your Binder to run the GitHub repo, and it can actually service website like graphic user interface, web user interface using Binder. So for some small project, I can using Binder to serve my simple proof of concept. In some case, just in some case, and by using Matplotlib and the Plotly or bokeh library that we are going to talk later in this lecture, you can use Binder for its full potential, because basically it gives you a free hosting of your application, your web application. Sometimes we are going to, when we train a AI model or doing some, maybe just some algorithm, develop some algorithm, we want to present it with a live demo in a web application. You can do that on Hugging Face. Hugging Face is a fine tool as well. But an alternative way of doing it is on Binder. So you can try it, and Binder works very well with Matplotlib or bokeh or Plotly Dash that I have used a lot. And Hugging Face works pretty well with Gradio, Dash also, and other more complicated things. But Binder works with simple things like Jupyter Notebook as well. Okay, then let's see the resource in our class repo. So before I go into the more details or more topics, I'm going to walk through the Jupyter Notebooks in the class repo. Because although I'm not going to explain it detail step by step, but I still want to cover the things that I wish to talk about in these notebooks. So you can see on the class website dss24.tjwei.tw. You can find the link to the class repo. Also, you can just go into the GitHub and finding the Data Science Software 2024. And in the folder called the 04 Matplotlib intro, you can find all these Jupyter Notebooks. I create one of the cartoon tigers notebook last night I haven't committed and push it to the repo. I will do it shortly. So you can also find the example about the cartoon tiger example. Okay, so the first one is basic Matplotlib introduction. It's mostly about the pyplot submodule. We usually import it as Matplotlib pyplot as PLT. It is more humble than NumPy or pandas that we talked before, because NumPy uses 2 letter shorthand like NP, and the pandas use PD. But Matplotlib pyplot use PLT. Yeah, but it is also a very common shorthand. But you can still use pyplot. People can understand it without trouble. PLT is just one of the sub module of Matplotlib, but it is probably one of the most frequently used submodules. A lot of course that teach the Matplotlib is probably just limited to the PLT. In our lecture or notebooks, we are pretty much the same. Most of functionality we are more interested is in the PLT part. But Matplotlib is a low-level library. It contains a lot of different functionalities. If you are only using a PLT and compare it to like seaborn or other high-level libraries like ggplot, ggplot2, things like that, a lot of people think that Matplotlib is ugly. It is not very visually pleasant. But this is not Matplotlib is designed for. Although PLT is sort of high level functionalities, but the true power of Matplotlib is at low level functionalities. Okay, anyway, we are going to use PLT and in the notebooks as an example. So you can see that we have we use NumPy to define an X that equally distributed between 0 and 1000. We can do that, and we can not between 0 and 1000, between 0 and 2 pi. And we have 1000 points in X equally distributed, equally distanted, and we can use PLT plot to plot the graph of sine X from 0 to 2 pi. And sine, this is a basic functionality of Matplotlib. And some people think this is too simple and not very attractive visually. But at least it is quite informative. And in fact, Matplotlib can do a lot of customizations to suit your need. So if you are using Matplotlib to create a graph, and the graph is not suited your preference, your design or artistic preference, that it is most on you, because in most of the case, Matplotlib has the functionality to customize its outlook, its appearance. So for example, if you think this line graph, the line is too thin, you want to make it thicker, you can do that. And actually, you can do much more. And if you want to change your font, you can do that. But anyway, let's first walk through the functionality of it. So this is what people think about Matplotlib, a simple line to plot the line plot, but it can actually do much more. So not only you can do a simple XY line graph, in fact, it is not just for functional plotting. It is not for function plotting. Although by this introduction, it looks like a function plotting. It is actually a generic line graph. Your X and Y can be arbitrary. Your X doesn't need to be like increasing or monotonically increasing. It can be anything. So if we plot it cosine X and sine X, it will definitely become a circle. So that's one thing you can do. And also, you don't need to actually plot a continuous function. If you use just like 5 or 3 points, that circle can become a polygon. So although our first usage of Matplotlib is to do a function plotting, to plot a function, like a function curve. And it is probably the most impression of people when people first see the Matplotlib, because we use it. It is maybe one of the more frequently usage of Matplotlib. And it is suitable for introducing Matplotlib. But Matplotlib can actually do a lot more, especially if you are creative, very creative. So that's why the magic circle example is useful, because we can use this sort of pattern to create some more complicated or more complex images later. So with the plot alone, we can already do something really amazing. But just remind you that this few examples just remind you this plot thing is more than a functional curve plotting. It is not just for a function curve. It's for every kind of line graph you can imagine. So with some creativity, you can draw things like this one or this one. These are just some variations of the things like this one and this one. And by combining this one and this one with different colors or different variations, different styles, you can already create something kind of visually pleasing and interesting. Okay, even with the simple function curve plotting, you can do more. It has most of the functionality you are think of, like a title. I didn't put title right here. Like legend, you can put legend right here. You can put multiple different curve on here. You can even customize the axis, the x-axis and y-axis, and you can have double or triple or many different y-axis, share a different y-axis. Sometimes we want to do that. It is usually not a good idea if you have two curves with different range, different y ranges. So sometimes each of the curve you may wish them to have their own y-axis ranges. If this is the case, maybe you should think about it twice. But if that is really what you want, you can do that. And you can have different line styles, like the dot styles, different colors as well. And in the legend, in fact, we can use a mathematical symbols like the text to generate the text here, but apparently I didn't do it right here. But in fact, it has the functionality to have mathematical formulas in its text. And it can actually have some like emoticon as text as well. Okay, one of the complaint about Matplotlib is it is ugly. It is not very visually pleasant as other libraries. It is not wrong because by default, Matplotlib does not. It has a really simplified or minimal design choice. So the graph that on right here may not suit the visual preferences of everybody. A lot of people doesn't like this graph, and they want to change the font, change the style. That's true. Although I was saying that Matplotlib has the functionality to do a customization, it may be a little bit tedious to do so. However, in recent years, at least there are many styles that you can choose to the Matplotlib. And by using styles, not only it can improve your artistic taste or like the attractiveness of these images, but also it also provides some functionalities improvement. One of the functionality improvement is like this grid. You can see the grid lines here. In a lot of styles, it turns on the grid on this graph, and also there are something like the color contrast. So one of the example is right here on the left side. If you see on the left side, you can see that one of the curve is not very visible. Although it is very personal that you may think the right side or maybe the left side is more visually pleasant to you. Some people like the dark background, and some people like the light background. That is one thing, but in the functionalities, you can still see that this line, because it is black, it doesn't feel very. You cannot see it very clearly on a dark background. So no matter what the theme, the style you are choosing, this one is a bad design because mostly not because of the dark background theme, this style, mostly because you are choosing to a dark color, a black color on this curve, on this straight line curve. So sometimes you can use these styles to improve your graph in different aspects, in functionalities or visually. And with some high-level libraries, in this case the seaborns, you can actually use Matplotlib to plot some very attractive and informative plots like this one. For the attractive part, this is more subjective, but I think most people will feel this image more attractive because they are more colorful and they seems to be more interesting. And not only because they are just seems to be visually pleasant, but also they provide more informations. In this box plot, it's kind of like a line plot, but it provides some statistic information like the 75 percentile or the median and the maxima minima of this kind of category data. We'll see it shortly. And also in this filing plot, it's not just this strangely looking, seems to be interesting, like artistic. The primary purpose of this filing plot is that it shows the distribution. It shows the distribution of each data sample, not only just the mean. Sometimes we use the mean to represent, or the mean and the standard deviation to represent the data. That is what statistics is about, because when we see 1,000 data, we cannot comprehend 1,000 data point. So we need to do some aggregation, like, okay, what's the mean? What's the standard deviation? To get a simple picture, simple overview of this data. But when you can see it in visual, when we do the visualization, we can comprehend more information easily at once. If we give you like 10 numbers, these 10 numbers may be as good as no numbers at all, because you cannot, it's just too many numbers. You cannot handle like 10 numbers at once. 2 numbers or 3 numbers is fine, like a mean, standard deviation, or maybe give you a median, or maybe just give you a minima and a maxima, and that's probably just all. If you give you more numbers, you probably cannot remember it. However, if we give you a picture like this one, you can easily see the distribution of this sample and this sample. So you can easily compare these two samples to see which one is bigger. Because, of course, some of the green one is bigger than the yellow one, and some of the yellow one is greater than the green one. But overall, you can see not only the mean is greater, you can actually see the distribution itself. And you know that the upper bound of these green guys is greater than the, although in general, green one is smaller than the yellow one. In probabilistically speaking, but it has a higher upper bound. So you can actually see these things in this graph. You don't need to check each number or writing a pandas query to evaluate it to check your answer. In fact, if you just see the data, you probably don't even know where to look at. But if you use a graph here, it can help you to solve your problem and to help you to do the observations. Okay, so although I said before, we are mostly focusing on the functionality part, the technical part. But like I just did, we still cover some aspect of what you should do with your scientific or data graph. So one thing that is your graph has to solve one of your problem or your questions. It gives you an answer of one of your questions. If you see a graph and doesn't know what the problem is and what the answer is, then you are probably doing it wrong. In this graph, we can see a lot of different things and answer a lot of different questions. So this one is a good graph. Another thing is that I want to emphasize is you don't have to do it just because you can do it. Because you have learned one of the technique like filing graph, the filing plot. Probably you haven't seen it before. It is possible that you haven't seen it before. It is new to you. And you are very interesting about this graph and want to try it on your next project to see what happened, because you have a new weapon, you have new tools, you want to try it. But just note that not every data is suitable for a firing graph. I see some people use the firing graph on like the green one, it only has 3 different cases. I mean 3 samples on green, like 5 samples on the yellow one, and maybe 2 or 3 samples on the purple one. So if you have a data set or a group of data that only have 3 elements or 2 elements or 5 elements, you don't need firing graph. Just like I said, when you have 1,000 samples, it is very difficult to comprehend 1,000 data. So you need to simplify, to do some aggregations in numbers or in graph. But if you only have like 3 data points in this the category 4 or 5 data points on category 5, you just plot these 5 points. You don't need this firing graph. It only makes things more complicated, unnecessarily complicated, and doesn't help you to see the truth. So sometimes just because you don't need to do it just because you can. Just one reminder. And also you can actually do the short pixel bitmap on the graph. It is very useful because like when we do some presentations or graph, maybe it is relative to geographically relative to a part in the world, maybe in Taiwan, or in some city like Tainan or Taipei or Kaohsiung, Taichung. In this city, you want to map this data like the population or maybe the location of the convenience stores. So it makes a lot of sense. You put this graph as an overlay on a bitmap, and Matplotlib can do it. And as usual, Matplotlib can do a lot more. You can manipulate this bitmap to do a lot of different transformation, a lot of different things. But here I'm just want to mention that we can do it. And we have another notebook that is doing some kind of image operations and using Matplotlib to present it. By the way, because this one is just too easy to show some images, so by using a bitmap directly, it's not allowed in homework. So otherwise you can do things is like paint something in a like a Photoshop or other painting program. You just do that and use Matplotlib to load that images. You can actually show anything in Matplotlib. Sometimes, in some cases, this is probably exactly what you want to do. To just use other software to edit an image and using it in Matplotlib. And that is, I think it is totally fine. But because in homework, this one is just too easy. So that prevent you to learn new things from Matplotlib. So this one is not allowed to do that. So, and also you can use Matplotlib to draw any kind of curve. There's something called a patch in Matplotlib. A patch can be a circle, a rectangle, a path, or a bunch of other things. But one of the interesting or more universal object is a path. A path can be like a polygon, like straight lines. But also it can be a smooth curve, which we call the Bezier curves. A Bezier curve is a one way to draw smooth curves. So you give 1 point, 2 point, or give its directions. It can give you a smooth curve without you to actually explicitly draw everything on it. And in most of the time, just by adjusting the intermediate points or the directions of, the gradient of these points, then you can get mostly what you want. It like if you are using like illustrators or like Inkscape or other vector design tools, chances are the curves that you are editing is some kind of Bezier curve. If you are interested in these things, you can check it on Wikipedia. The explanations in Wikipedia about the Bezier curve is pretty good, and it have different orders, like a quadratic, a cubic, and maybe degree 4 curve. So you can see that the curve 3 and curve 4. In Matplotlib, if you have a curve 3, you give it 2 curve 3 together. And if you have a curve 4, you give it 4 curve 4. You have need to consequent 3 curve 4 command to form a actually curve with 4th degree. Because it's like a polynomial. You need 2 points to determine a straight line. You need 3 points to determine a quadratic curve. You need 4 points to 4 numbers to determine a cubic polynomial. It's kind of like that. So you need to like these 2 points to make sure this curve, because we have a start point and 2 intermediate point. One intermediate point and 1 end point. So this one is actually use 3 points to determine this curve. You need 3 points. So maybe it's a quadratic sense, but anyway, you need 3 points. 2 actual point explicitly, and 1 point that is like the operation before these curve 3 operations to design a curve. So you can, if you have a reference image, mostly like a cartoon, anime or manga reference images, you can actually trace the curve and using these operators to mimic anything you see. So in fact, even if you are kind of intimidated to this Bezier curves, you can still use polygons to approximate anything you want. Okay, so this is another example that this kind of operations can do. You can actually achieve things as complicated as this one. But in this one, I'm kind of cheating. Actually, I cheat because I'm using a SVG files. I'm reading an SVG files, but I translate into things like this one. So if you get an SVG, not too complicated, mostly like this automatic generated SVG, and use this code, you probably can generate things like this one. But this code is not universal because I have some assumptions right here. So I haven't tested it on too many SVGs, but in principle, you can render any SVG or vector graphic using Matplotlib. So because this is too easy and kind of cheating, this method, you can use this one. You can use this one to handcraft or to trace, even trace some images. You can trace reference images if you wish to do so. That's totally fine. But do not just download an SVG and using it in your homework directly. Do not do so, because it's too easy and it will prevent you to learn things. I mean, if you really do so and you generate this kind of things first, then you put it in your code without mention that what SVG is, without showing the original SVG. Or maybe you can use Inkscape or Adobe Illustrator to do the tracing, and then generate an SVG files, then translate in this code. I think this kind of things is not easily detected. If you are using the bitmap, then the bitmap has to be presented, or maybe even if you translate it into a NumPy array, then we can easily detect that, okay, this is not allowed. But because we are allowing you to using your handcraft this past data, so I know that if you really want to cheat, it is not detectable. It is very detectable in your the homework. But I mean, the goal is just to help you to learn more things. We do what we can do, and I'm just saying that try not to just use one of the SVG files to do so. But on the other hand, I think it is still very interesting to like what the things I'm doing, like translate one of the SVG files into the language of Matplotlib and showing it on things. Sometimes it may be very useful, and sometimes you want to trace, like what I said, using Adobe Illustrator or using Inkscape, that which is an open source alternative to the Adobe Illustrator. To draw vector images, you can just trace the images, the outline of images, and you get an SVG and translate the curve, the Bezier curve, into the language of Matplotlib. Sometimes that is kind of things that interesting and useful, because after all, it's something that we do when we do the image annotation. If we do the like object detection, we do a bounding box using tools to do the bounding box, and we read the bounding box back, and we do something with this bounding box. And sometimes we're not using a bounding box, we use a polygon to do the annotation. And sometimes we actually not using we use a smooth curve to do our annotations. Sometimes we do that, and we are going to read that data into our program to do the machine learning, to do the training, or to do some algorithm. So sometimes that is what you actually want to do. And sometimes you can do that just for fun. Like you get this data and try to fit it into some machine learning. Like if I tracking this like a wheel, like here, and do the machine learning, we probably will learn a circle-like function. And maybe I track this mouse, Mickey Mouse. Oh, by the way, this one is the copyright of this version of Mickey Mouse I think is expired, and I get this image from the Wikipedia. This SVG files from the Wikipedia. Okay, so maybe if I trace this outline of the Mickey Mouse here, maybe I can get using machine learning to learn this curve as well. That might be a very interesting thing. This is very similar to our next homework. to learn things from one images in a very unusual way or different way. But that's for next homework. So for this homework, just try to use this homework to learn as much as you can. Okay, so but Matplotlib is a low-level library, so you can use seaborn, a high-level library that is based on Matplotlib to do your plot. Personally, I don't use seaborn a lot. But this is one thing that you can use to, especially when you wish to draw something good looking. And this is a type of the graph that you can find in seaborn. Then you do that. But for me, because I usually draw something that is unusual, and I don't really care about the attractiveness of the usual, I mean the plot graph or line graph. I'm more focusing on the informative. So sometimes I do a lot of adjustment. So I am more familiar with Matplotlib than seaborn. But if you are trying to do some presentations, I think seaborn is a better choice than Matplotlib, because you're not trying to do something funny. You just try to communicate with your audience to represent your data visually, to provide information. Then seaborn is probably one of the good choice. So for example, this one is what we'll go to seaborn more detail later, but you can see that it gives this plot. You can easily plot this one in seaborn. Not so easy in Matplotlib, but you can do this quite easy in seaborn. You only need to provide the information. What is your x-axis? What is your y-axis? What is the color? Or what is, in this case, it doesn't have marker or styles. But you simply provide like a form. You simply fill in the information, and you get your part. And it has a pretty nice default, and simply use it is pretty good. Also, this is the data that it is going to represent, like the we're going to see this data a lot because this one is embedded in seaborn. It is a statistic for people who tips in a restaurant. So it has different columns about things like what is the total bill of this meal and how much tips it gives in this meal. Who is the person who paid the bill, and how many people are there to have the meal, and is this person a smoker? Which weekdays are it? Is it Sunday, Monday, or Tuesday? Is it a dinner or lunch? So we have this kind of data. And this one is because we are mostly interested in tips or bills. So in this graph shows the total bills, the relation between the total bills and which day, like Thursday, Friday, Saturday, or Sunday. And depend on the smoker or not, we want to see whether smoker pay more bills or not, or is there a difference? People are willing to pay for a meal, depends on whether it is a weekend or a weekday. So that sort of questions we can answer in this. We can answer those questions in this graph. We can see that. So that's what makes this graph informative. And by the way, one of the rules I usually talk about is that you have to know your resource before you do anything, including do the plotting or graphing. So what resource we have in this graph? We have x-axis. We have 1 dimension and 2 dimension because we are drawing things on plan. So dimension is a thing that we can use, and it is very precious because we only have 2 dimensions. But usually our data, like pandas, it has multiple columns, so it has a very large dimensions. So we have to choose the dimension, the columns or features carefully. In this case, we actually demonstrate showing 3 different dimensions, like a day or total bill and smoker. However, because smoker is just a categorical data, so it has only actually it has only 2 categories. It is a binary data. So we don't want to use it to waste one of our precious dimension. The bill is a continuous number. Total bill is a continuous number. And the days, we have 1, 2, 3, 4 different days. So we share the x-axis with our 2 different categorical data. And the primary, it is primary for the day, and because the day has more categories. And for smoker, it is more a minor factor for the x-axis. But we also use a color because not only we can use the x dimension and the y dimension, we can also use colors. You need to be very careful about colors because people may have different perception of colors. And some people may have difficulty to perceive colors. So you need to be kind of careful. But at least you can use some the darkness or lightness between the things. And the colors is still a very powerful thing that I can use. And also we can use size. And also we can use shape, different shapes of things. So that is the weapons or resource that you can utilize in when you do a graph. But still, they are very limited. Only X and Y has kind of continuous. The color is also continuous, but like we said, some people may have difficulty to perceiving the colors, and also the resolutions of the colors is not great for human. You probably can only have like 10, 12 level of different like the colors. Maybe you can use it to like in 2 or 3 channels, but that's all. And they are low resolutions and they have some limitations. But anyway, that's something that you can use. And also the size. I think size of things is probably, size is part of the shape. But one of the important things is the size. So just first realize you have to limit. You have a limit number of dimensions that you can use, and some of the dimension is more restricted or limited than the others. So choose your dimension carefully. Choose your features carefully. So right now we have 1, 2, 3, 4, 5, 6, 7 different features. We need to choose some of them and discard some of them. And some of them are more like categorical data. So even the size, the size of a group is theoretically it can go up to like infinity. 100 and 200. But in practice, it probably should be less than 10 and typically less or equal to 4. So it can also be considered as a group, categorical data. So it is not that bad. So you can probably choose them wisely and use the visualization to help you to observe or answer your question. So that's another is also doing for the data like before. Also, but like I said, these plots are not only vibrant, it's just not visually pleasant, but also packed with valuable information and using the tools and the resource we have wisely and carefully. And a lot of different variety of graph people use for times. So you can see when you read paper, you may see, okay, this kind of graph is really good. I can get information easily. You might have seen a lot of different type of graph. A lot of this type of graph that people think useful is implemented in seaborn, so you can get them immediately and use them quite easily. Because if you are interested, you want to show this kind of graph, chances are other people want to use them as well. And if a lot of people want to use this kind of diagram or graph, chances are they will be implemented and easily used in seaborn. Or at least you can search the issues. Maybe people are filing a request or feature implementations in the seaborn issue trackers. And maybe some people will answer some solution to it, even if it is not already in the seaborn library. But back to the primary goal of today's lecture, we are mostly do the technical part. Even if you are very limited with the understanding of the detail of techniques, you can still do very good graph if you understand some principles. But if you know your weapons, like you are trying to cook something, but you only have one knife and one just one spoon and just one limited set of cooking tools, you can still do a very good things. The data is like the ingredients that you are going to have. And Matplotlib and these coding tools, like the tools you are going to use for cooking. So it really depends on the tools and the ingredients. So if you have ingredients, good ingredients, and you understand how to cook, you have a fundamental understanding of how people like to taste of food. With very limited tools, you can still do a very good job. But if you understand a lot of different tools, if you have some stuff, fancy stuff, and different type of cooking tools like microwave or ovens, very advanced professional ovens, and professional knives for different kind of meat, then that is your advantage as well. And in one case that your tools is so limited, you only have one spoon, then you probably cannot do much. Because there's one saying that if your only tool is a hammer, then every problem you see is a nail. And that is probably the case at the very beginning of your career of a machine learning data scientist or data engineer. So that's why we are focusing more on the tools right now. Okay, so this is my way of learning a library. Like I probably mentioned before, I'm going to focus on one topic or one problem and trying to solve this problem. No matter this problem is so kind of silly or useless. Because when you reach a new tools, you probably don't even have a right problem for that kind of tools, or you don't even know. I mean, you probably have a lot of problem or issues that might be solved by these tools, but they might be the primary problem people use. So that is fine. You just give one problem and try to use that library to solve. Just don't give up that library so fast just because it cannot solve your problem perfectly. Just keep that in mind. Then every problem is a good problem. So one way or another, maybe someday you will find a suitable problem for that library. But any problem or any library is good. The combination between any tools and any problem is good. Just keep it in mind. If they do not work together, it may not be the fault of the tool, the toolbox. Maybe it's just not suitable for this kind of problem. However, when you learn something for a while, like I already know the Matplotlib a little bit, and I can see people can do amazing things by using Matplotlib, and I don't know how to do that. One way to improve yourself is to do silly things, because some functionality is not frequently used. The frequently used functionality you probably already know because you are using Matplotlib or this toolbox in your daily life. If someone is better than you, it's probably they are knowing more things than you do. So in order to learn new things that you will not usually use in your daily life or previously, try to use this library to do something wrong or not suitable for this library. So this one is the case. We're trying to mimic a matrix circle by using the py plot alone. We are not using the patch or pass or those kind of things. We are just using the py plot to and try to learn things. I use this one to learn like mostly for this thunder like aura like things in Matplotlib. I'm mostly using the filter, but I don't think this is quite useful. Although I learned this kind of thing, but along the way I kind of understand Matplotlib more. But still, the things I have learned is the filter. The primary things I have learned is the filter features in the Matplotlib, and I know its limitation. But till now, I don't think I use it a lot. I just know what it is. There's some minor things I learned along the way. It's quite useful. But the primary things I learned in this project is the filter, which I haven't find a situation that I have to use it or I can use it to make a big difference. But still, I think the journey worth it. But anyway, that's just saying, this picture just showing something that you can do a lot of different things by using Matplotlib. In previously, we are given this as a homework and let the student to do different magic circle. the process is that try to find an image of magic circle on the internet and find something that really interests you. Try to use Matplotlib to mimic that things. Maybe not 100%, but just get the feeling that kind of touch you. Because when you see a magic circle, you see, okay, this one is quite beautiful, and try to and kind of fancy, and try to mimic the effect. So maybe not just the thunder or aura or like this kind of thing. Maybe other kind of stuff that is interesting. Try to mimic and use it. So these are some of the good examples that I get from the homework, and I think they are quite even better than the original one that I designed. And also, there are some functionality about the font, especially if you are a CJK, like the Chinese, Japanese, Korean users. You wish to have like the character, your text, like Chinese text on the graph, like in legend or in title. Sometimes you have to do that. So maybe the font or Chinese font is usually a issue in Matplotlib. So this font notebook is demonstrating how to use font and list the font available. So one of the issues is people don't have the font installed in their system. People have different set of font. So at least you should list your available font in your system. Of course, you can also use TTF files or font files and just load the files as well. You can do that. Some user case is that you can use the emoticons like this one. These are just not exactly the emoticon, but they are the font that in Unicode. And you can, or in some font files, then you can use this font in your graph if suitable. When it's suitable, you can use these icons to make your graph or your part different than to make some difference between your part and other people's part. Sometimes good is not good enough. To make your uniqueness is your strength. So I can imagine that using these icons to make your presentation unique to others. So again, this is just a choice. Sometimes it's not suitable for you. It's not suitable for you. But by knowing that the possibilities, you can choose your design wisely. Okay, another notebook is about the hybrid image. This kind of image is something that when you see it in a close range and when you see it in a long distance, it will appear differently. When you see it more in a short distance, it will look like a picture of Albert Einstein. And when you look in a long distance, or maybe you take off your glasses, it may be like a Marilyn Monroe. So this is kind of interesting using a high frequency, high pass filter or low pass filter. So this one is a famous illusion and use this Marilyn Monroe and Einstein specifically, but I'm choosing a different images. I mean, they are celebrities, so they have a lot of different images. So the original effect is also using them as an example. It's just they pick different images. So I reproduce this experiment using this notebook. Okay, so let's summarize a little bit about how to learn Matplotlib or other plotting library. This is not generic for learning every library, but I think this is a good idea for learning Matplotlib or other plotting library. Is first, learn by basic examples. All of these libraries are, their architecture is and the concept are quite complicated because they have to do that. If you have design web applications for drawing things, or if you actually coding a painter, you will understand how difficult it is. Because, I mean, if you are just doing a simple canvas and putting things on it, it is not that difficult. But still, there are a lot of different things you need to consider, like efficiency. If it is client or server side things, showing image takes some time. So if you want to take some bandwidth, so it needs to be quite efficient. So you'll consider some efficiencies already. But things get more complicated when you are going to design things like undo functionalities and provide more things like vector images, vector graphics, things like that. Things are going to be more and more difficult. A lot of things need to be considered, and it is not easy to make it correct. To make everything correct, like the thickness things or a lot of details. When I first learned programming languages, one of the projects I do is doing a painter in different levels. I mean, I made a lot of different painters. When I learned the basic, when I learned C language, when I learned C++, when I learned like new framework like Windows GUI, Windows 32 GUI systems. Every time I learn a new things, like my Qt, or like GTK, I do several projects like a telnet client. Because telnet it was one thing, once a thing, a major just like a web browser, but it much easier. And you need to handle some strings like the NC escape sequence, control sequence like that. And another thing is a painter to paint things like loading images. So and back then, even if you want to draw a straight line or draw a filling things or dynamically interactive user interface to draw a circle, you need to make it greater or shorter, like the mouse interactions. It will make things very difficult. And I never write a painter that gave everything correct. I make a writer. I like I said, I made a lot of different versions of painter, and they always kind of works. You can draw some triangles, draw things like that, but they are always some corner or edges that is not finished. There also always something that is not satisfied. I mean, I can use it because I know the program, but I know this thing is not easy to good for. I mean, if I give it to other person, they probably will complain a lot about the features or not intuitively, or a lot of things that kind of unable to do or need a very strange way to accomplish the job. So I know how difficult this system is. So usually the plot library, especially they want to make it more user friendly, they have to have a very large fundamental infrastructure. They have to a lot of foundations they need to build up before it can do things very well. So the framework is complicated. Not because they want to make it complicated, because they have to make it complicated. So the second step is to understand the fundamentals. They may have different abstraction of the things, like what a graph is, what a thing is. So the first step is like learning the basic example, and the second step, after you know how it actually works, like using an application, try to understand the fundamental things about it. Not only for Matplotlib or Plot library, if you are doing something like a design things, like you are using a video editor, like Premiere Pro, like Adobe Premiere Pro, or something similar, or you are using a 3D applications like Blender, or maybe like a game library. There are something like step 2 here. You first learn by basic example, but because they have to have a very complicated architecture, you need to understand the fundamental architecture of it. These applications are success because they have good infrastructures and good they have developed a very good fundamental ideas about concept about the things. They are doing it right so that they can success. But there are many different ways to do that. There are different ways to do the abstraction. So some people are doing it differently. They are similar. They are similar. And people are learning from other projects a lot. They communicate a lot. So they are something similar. But every software, their idea are sort of different. Like if you're learning things from like Blender, you probably will find similar things in other softwares, but they are sort of different, not exactly the same. The same thing here is Matplotlib. So you need to understand some fundamentals in order to be more advanced. Then a good thing is to learn by advanced example. We'll show you. Just look at the gallery or the things other people do, and try. If you find it interesting, understand it. So you will find a lot of different things. So there are a lot of things you can. This is a very long journey for step 3, and probably you will never reach the finish line. But you can improve it by step 3. I think we already passed the step 1 because we have already shown some basic plot and things. If you have already followed the first or second or some of the Jupyter notebook, I think you are quite good for step 1. So we are going to step 2. There are different components in a Matplotlib. So this one is a title, and this one is Y label, and this one is X label, and this one is called the tick, the tick label. So by knowing the name, at least you can search it with the right term. I think it's quite important for your learning. I stuck with step 1 for quite a long time because I kind of didn't bother to understand the right terminology. Finally, but I understand that the terminology is quite important. So if you understand the terminology here, then you can search your answers more efficiently. Okay, and these are some of the component over here, and the greater thing is called the figure. I list a few of the component. The most important, the critical component is right here. The first one is the figure. This is the whole figure of it. And the child of a figure is axis. So the whole thing is figure, but the major part things is axis. You can have a lot of different axes. So when you have a subplot right here, you will have 4 different axes. If you just have the graph we showed before, mostly have just one figure. One axis. But you can have different, a lot of different axes. So each axis is our main drawing area. You can set the background of this axis. So sometimes if you want to change your background, you were trying to, figure set background. But after you set a background, you see the border things, the padding things are getting changed, but not the actual graph things. You got stuck because the thing in the actual graph, actual plot lying on is actually called axis. You have to set the background of the axis, not just the figure. And also, we usually could create the axis with PLT subplots. So you can have different subplots and have different names right here. And there's also a name called axis. The axis is simply the x-axis and the y-axis. So a lot of things you need to modify is like the tick. How many ticks you should have? This belong to the axis, or the range between x and y is also belong to the. It is showing on the axis, but you can use axis to change the limit between. The range, display range between the x-axis and the y-axis. And other things, almost everything that you can show on with Matplotlib is artist, like a figure, axis, and axis. And there are also other objects like text, line 2D collections of object and patch object. So all of these things are objects in Matplotlib. In other libraries, there are similar things, but may not be exactly the same. But by understanding this kind of things like the object, you will understand the animations much more easily. Otherwise, you won't understand what happened to the animation of Matplotlib. Another concept about a architecture is the backend. The Matplotlib has different backend. If you are only using the Matplotlib in a Jupyter notebook, chances are you only know the Matplotlib, showing it using the Matplotlib inline. In Jupyter Notebook, it also has like IPYML backend, things like that. But the thing is, the Matplotlib is a rendering engine, kind of decoupled with the backend. You can choose different backend that works with Matplotlib. Some of the backend are just exporting some images. Some of the famous of them are the PNG. It actually called the AGG render, the raster graphics, and it can output PDF and PostScript PS file and SVG. It can actually output SVG files. And PGF is another graphic vector graphics. And there's also another render, Carol. Carol is a render engine to either raster or vector graphics. Use a lot in it says that in Python there's a library called the PyCarol or Carol CFFI, C foreign function interface. But the Carol itself is not written in Python. It's just a general library that you can I think it's C library. I'm not sure it's written in C, but it I think it's used by GTK or other libraries as well. But in Python, you use PyCarol or Carol CFFI to use this engine. If you search some image-related things, you may find that the answer will ask you to install and import PyCarol, because this is a popular engine for dealing with PNG or SVG, or even PTF and PS. But there are also some interactive backend that is more kind of interesting. If you run Matplotlib without the magic like Matplotlib inline and you run on your local machine, it probably will open a window, a small application window, and you can see these interactive navigation things. The interactive backend, they have different interactive backend like a Qt AGG, and IPYML is work in Jupyter Notebook and also in the Jupyter Notebook of Visual Studio Code. And it also has GTK3 AGG and TK AGG. TK is the TK Inter built-in GUI library in Python. And in Mac OS, it also has a Mac OS X. I mean, this is just I cut this list right here because this list is so long I cannot fit it into this image and also make it readable. Just saying that it has a lot of different interactive backend, so that you can just pop up a window that you can use your mouse or keyboard to interact with it. You can zoom in and browse. If you fit it into several different images, you can browse the first one, second one, and third one, and so on. And also it can demonstrate the animation. If you are using the animation function, some of the interactive backend can show the animation. If you are rendering a 3D plot by using these interactive backends, at least some of them, you can actually navigate through these 3D things. Okay, so that is really brief and short of what the fundamental things it is. If you want to dig it more deeper, you can read the document in the official website. Okay, the next thing is learn by advanced examples. Before we go to the examples, let's go back to the homework. Since we already learned more things, discussed more things about Matplotlib, let's go to the homework for more details. So like we said, we can use patch to draw anything. This is one thing you can do. I think there are two approaches for this homework. One is using this past data patch things and the circle, and the other is using the including this Chaohu tiger. They are using the patch scenes. But you can also do things like using mathematical formula, using the plot scenes. Depends on what you wish you can learn or accomplish it. Because if you are trying to elevate your skills for drawing things like a graph, like a line graph, scatter graph, or like understand the techniques behind the seaborn things, you can use the PLT functions and without using any of the patch or paths. So that's one thing you can do. You can use PLT or Quiver. It actually have like drawing a contour or like drawing vector field. So it can already drawing a lot of different kind of things. Not only just curve, it can draw like a heat map, drawing a contour of things, which we will see in the advanced example. If that is something you want to do your homework, you can find out the similar examples, which you can see in the official site, or you can search on the internet. And by mimicking the example and adapt the example to suit your needs, you can already draw a lot of different things without using patch or paths or any other things. The other thing is like what we do for the NumPy. If you only want to draw things using circles, like ellipses, like this 椭圆, ellipses, you can follow this one, and this one is mostly, actually it's almost exclusively done by using ellipses. Let me check. I don't even use circle. At the beginning, I use a circle to draw the face. The face is still circle, but I use ellipses a lot, so that I write a function to wrap the original ellipses, so that we have ellipses with outline, the black outline. And because the circle right here is actually needs an outline, so I don't even use the circle anymore. I use the ellipses with outline, and I draw the mouth, the face, the tongues, and you can see that the tongues are only shown in the mouth because there's a function called the clip. So by doing so, you learn some of the fundamental functionalities of, or some tricks in the Matplotlib. So maybe you want to draw an image that is clipped by a shape. That is actually doable. I mean, if you have an Albert Einstein image and you want to have a round shape, you can actually do that. Or like the Chaohu shape, but showing the Albert Einstein, you can do that. You can do that. So this is a demonstration of, this is just a ellipsis, but it is clipped by the other, by another shape right here, the mouse shape. And the mouse shape is also clipped by another big circle. So we can combine these circles together. Also, this one is arc. Technically speaking, this is not an ellipsis, but this one is an arc. I probably can also do this with ellipses without filling things, like doing the outline and clip by cleverly clip by other things. But there's a function called the arc. So I'm also using an arc to do these hairs, the facial hairs, and these eyebrows here. And all other things are just ellipses, like rotate ellipses and with different sizes. And even these marks or stripes on the face, originally they should not be ellipses. They have something more complicated, but I approximated with some ellipses. And then also on the nose should be some polygon, but I use ellipsis to replace it. The only thing that is not an arc or ellipsis is the nose line here. I'm using a rectangle. That's all. But of course, you can still use ellipsis, a really narrow ellipsis. That's kind of like a rectangle. You can do that. But I didn't bother to do that. I probably should use a path, but anyway, this is what it is. So you can do things like this one by, if you think you are already familiar with the plot things, but you are not familiar with the patch things, you can try to use this homework as a small project to learn the Matplotlib patch instead of using Matplotlib pyplot. Also, if the circle sense is not enough for you, you need arbitrary paths. You can also use the. It is also including in the Matplotlib patch, but it's called the path. The path is a more free form of things, even more free than the polygon. I didn't use the polygon there, but if you want, if polygon is what you wish to have, you can also use the polygon to compose a interesting enough images. But here, I'm using a path to construct this arrow here. A strange arrow, like one is smooth here, and the other is kind of like orthogonal to each other. So you can use these to construct even more complicated shapes than this one. This one is just a random, kind of just random experiment. It's not quite good. It might be too complicated for this kind of a shape. You probably don't need this kind of a detail. And you probably need more objects than just single one to make it more interesting. But you can do things like this one. And you probably can also combine things like this one with this one. And by using mathematical formulas and you can fill in between two lines, two circles. You can actually using PLT, pyplot to draw things like this one. Kind of like what we do with the NumPy homework. I think the best way to draw this mouse is probably using a path, and with some mathematical formula, because I can give a point right here, a point right here, and point right here, and it might look kind of like a quadratic polynomial curve. So I probably can combine the mathematical formulas with the power of paths together to easily contrast things. Here is just using a stupid way to do that. I always using ellipses, just try to demonstrate by using the circle or ellipsis alone what kind of images that we can actually generate. So this may not be the easiest way to do so. You can do your experiment and your project using this homework. There are a lot of freedom in the homework, a lot of interesting topics you can try. Okay, so let's go back to the third topics here. Is step 3. Learn by advanced examples. First examples is that you can actually using event handling on your interactive backend or interactive windows. When we say interactive, means we can actually click. You can use your mouse hover over this image or click some positions. Your program can receive this event and you can have a callback So the callback will handle the event and update the image accordingly. So in principle, you can design a game, 3D or 2D game, by using Matplotlib and NumPy. And this one is my videos, although it is in Chinese, but it is a detailed explanation of how to achieve a game interface, game UI interface by using Matplotlib. I don't think this is the best tools to do things like this one, because we are going to introduce Dash later. But I still think in some case this one is worth trying. I can imagine some scenarios I will use this Matplotlib things as UI things to show some result of some of my experience or my researches. But first of all, I have never done serious things using this as a UI because I know it has some limitation. And secondly, other tools are advanced rapidly. So I really doubt that I can do much more things in the interactive UI and make it useful. But still, it is interesting. And sometimes when maybe you are not building a product, you are just running a GP notebook. You are using Matplotlib for like plotting or doing things. But you find out, okay, in one moment, you need to have some user interaction, like drawing an area, like drawing a bounding box, or you have an image viewer. You have to has a user input. Like if you are using the meta segment anything, the prompt is a point. You want to segment a thing. You need to give some points. Then probably it can be done because Matplotlib has a UI interaction, so you can receive the mouse click event and get the location of the position where the mouse clicked, and use it as an input of your meta segment anything model. Sometimes I can still imagine that you can employ these techniques in your workflow. So if you are interested in this kind of things, it's not difficult. It's not difficult. And maybe if you are interested right now, you can see the video and check out what and do some experiment and learn these things. But I think another way to learn these things is when you do your project, and at one point you need to have event handling, and you are already using the Matplotlib. Then this time you can probably to search the examples, maybe not this one, maybe the other one, but search examples and by following the examples. So then that's I think that is one way to learn how the event handling. But before you can actually to do that kind of things, you need to know that Matplotlib has the functionality of handling event like mouse click. Okay, one thing I have to remind that the drawback of using this Matplotlib things is it doesn't have a fully developed UI interface. I mean UI widgets like a click button or like a text input field. So that makes this not suitable for developing a fully work applications. But still, I think it is convenient for just one or two shot user interaction things like here. Another functionality of the Matplotlib is 3D plot capabilities. Like these scientific 3D things like a surface plot or like a wireframe plot, it can actually do a lot of things, like what I am going to show right here. This is one of my recording of previous class. I can actually load 3D models inside Matplotlib and navigate it. And this one is a quite old video. So right now you can actually do it in Jupyter Notebook. You can actually show the 3D image and navigate inside the Jupyter Notebook alone. But before that, it is impossible to do so. I have to have a new Windows pop up to do the interaction. You can still, back then you can still show the 3D image inside the Jupyter Notebook. It just you cannot interactively change the viewpoint or zoom in, zoom up. It's just a static image. But right now you can actually do that in, this is example showing it in Jupyter Notebook back then. Right now you can do the interactive things in Jupyter Notebook, but I still think it kind of lag and slow in Jupyter Notebook compared to the window, the dedicated window. And also you can do animations. So this is also another simple animations that I do using Matplotlib for quite easy. Just different scatter plot. And the interesting part is no matter what this data is, you can see in every time moment, the X mean, these are just a lot of data points. Each point is a data. It has two features, a X coordinate and a Y coordinate. So if you consider all these sort of points, the mean of X is maintained to be 0. And the mean of Y is always 0. And their correlation is always 0. And the standard deviation of X is 1. Standard deviation is 1, just like the standard normal distribution. But this video is demonstrated that the mean and the standard deviation alone, and the correlation, of course, the correlation, mean, standard deviation alone does not tell you everything about the distribution. So although the distribution is kept to have the same mean, same standard deviation, same correlation, I have enough freedom to change these pictures to things like this one. So you can see that for these images, I have to make it a little bit upper because it is more heavier right here. So to keep the mean to be 0 at the origin. So the graph is kind of more towards the up right side, not in the center, not aligned in the center. And also, this picture is a little bit skewed. You can see that because I have to make the correlation and the standard deviation to make them to be 1 or 0. So it has to be a little bit skewed. You can see, especially if we have a straight line like right here. But at every moment, even if with this one, it looks like it is scoring up. It is, but the thing is, it's just the movement of the data points. So there's no data point. Every data point is just moving. They are not clipping out or eliminate. So for every single moment, we keep the same standard deviation and the same mean and correlation. Okay, so how do we find example? The first thing you can do is the official website. It's kind of like a window shopping or looking from a catalog to do the shopping. Sometimes you may receive a catalog from a shop or a department store, or maybe like PC Home or Momo or something like that. You may want to look through it when you feel boring to see what kind of items they are providing, and are they getting a discount or things, a promotion of things like that. This is the mindset you will have when you're looking at this gallery. Another situation is when you are in an emergency. I mean, when you need to draw some graph and you don't know how to do that, then that is another good timing for looking at this category. You're trying to look over this catalog and find the thing more similar to your needs. This is more like you are trying to buy a computer, trying to buy a mouse, trying to buy a things, and you go to an online store website and do the search and do the shopping to see the photos of item, to see whether, and try to find out something you need. This is another mindset you can have to see these examples. But all of these libraries, the plotting libraries, they will have some galleries or example sections and provide a lot of examples that you can look at quickly. So for example, right now I'm just accidentally click through a link, but just give you an idea what you can find in this gallery. You can find a lot of different examples right here. So if you are trying to draw something like Firefox, like in homework, you probably will want to find this, how this is done. If you want to draw some thing like we see in the anatomy of a figure, you can refer to this example. But anyway, you can see that animations, 3Ds, and a lot of different things. Sometimes you may disappointment because when you click through it, you find out this is not what you want. That's okay. You can just scroll through to find another example. So it already got tons of examples, right, in its example section. We're going to walk through for a few of them. Okay, the first thing is these examples that is simple plot or bar graph. But there are different choice of, even with a simple bar graph, you may have different layout and choices. Like sometimes you want them to be side by side. This is called side by side group and side by side. And sometimes you want it to be stacked together. And if one is always smaller than the other, like a blue is always small, less than the orange, you probably want it to be overlay on it. And sometimes you want to stack it, like stack on it. So in any case, you can see the example. The default one might be just like this one, but sometimes you want this one. Then just check the examples and click through it, and you can see how to do it. And sometimes you want to make it horizontal, make it something like this one. I don't even know why we need this, but if you want this one, like broken things, you can use this example. Now, even with that plotting things, there are some variations. Sometimes we want to have a histogram in different styles, different. This one shows a style of it. They have different styles in the gallery, in the examples. But this is just one of the interesting and colorful things I picked to put it in the slides to give you an idea. what is the possibility you can get from this gallery. And at the previous examples, they are mostly about the informative part, not about the visually pleasing, or although they are colorful, right? They are colorful, but they are mostly doing it because we are trying to show things in a graph. And the color, because by using different color, we can differentiate different category. Or using like, even with this different pattern right here, the different hedge field, we are trying to differentiate different type of data. They are more functional than, even with this one, we want to group together because we want to compare them side by side. This is the major thing we want to compare. And the secondary things we can compare is the same, the different group with same color. So all of this color or layout or design served with the purpose of showing information. And a little bit of them are making it more eye-pleasing, visually pleasing. But sometimes I'm not those kind of people usually. But sometimes even I have some preference of some, like the font or design choice. This one is more like a design choice. Matplotlib can do that. This is just for the drawing style. If we have two lines right here, what is the style of the angle part connecting these two together? Like you can have this one called the mitre and the round and the bevel. You can imagine if you a professional designer may think the huge difference between these different things. For me, they are just two kind of things, round or not round. Because round and some more edge kind of different, kind of have some differences. But if I'm trying to show an image, I don't think this is a primary concern. I still think, I mean, even with, to be honest, even with a round, the radius of the round edge is still, I can still tell the difference between, and I still have preferences between how round it is. It just, I think the information part is more important. So that, I mean, if you are generating a graph and showing it to me, I won't be very picky about, okay, you are using a edge here. You are presenting a image for like a target for like children, and your image has a very sharp edge. You are delivering a contradict message in your graph, like those kind of thing. I'm just making it up. I'm imagining things like this one. I don't really care about that. I can see that, but if you are, I don't question your judgment of the visually present. I'm more focusing on the information that you are presenting and whether it is answering a question or not. But the purpose of this slide is showing that you can, if you are using Matplotlib, you can have different choice. There are a lot of things you can customize with this kind of small edge things. If that is the things you want to achieve, you can do that. Not that you have to use it, but you can do it. This is another demonstration of the graph, informative graph that you can have. Just in case you haven't seen these kind of things before. All of these things are serving different purpose. It is still a bar graph, but we are very difficult to compare like orange and the green. We can only compare the red things. and have a rough idea of the composition of differences. To be honest, I don't think this graph can answer much questions. It can give you a general idea, but it is difficult to compare the yellow things. So if you want to find out which question have more people to have the yellow answer, then you probably have to look over through each of them, not just by one glance. You have to look through one by one and find the largest one. I think this graph can show is because, I mean, the label are strongly disagree. And this is kind of in the middle, and agree and strong agree. So it is easy to compare like the red things and the green things. I can easily find this one is the largest. The questions 3 is the question that most people strongly disagree, and I can find out the question 3 is the question that most people at least disagree. I mean, they are strong disagree or disagree, because this point I can find out. And this one is the second one, the third one. And for the most people, if we consider agree and strongly agree together, this one is the most one, and this one is the second larger one. If we consider the strongly agree alone, then this one is the question 5 is the question that most people strongly agree. So this serving the purpose of this kind of questions. It can answer this kind of things. But if your label is not in an order, or the order is not kind of like this agree or strong agree things. So for example, it's like apple, orange, banana things. Then this graph is not suitable for this kind of data. Okay, then if you have seen this sort of things in a paper and you want to apply on your research presentations, then one way to do that is, okay, I don't know how to do that, but when you look through the example galleries in Matplotlib official website, you can find similar things and you can use it. And the other thing is like very common to see like the 2D distribution, and when it project to the one dimension, you can have a histogram like this one. And you probably, similar like this one, you probably have seen this in other research or other presentations. And you don't know how to do that, you can follow the similar approach by surfing through browsing through the catalog in the gallery and find out similar things. And this is as well. But this one also demonstrates some interesting things like a mathematical formula in the text. And it actually shows the idea of using dimension efficiently. We have 2 dimensions, x and y, but we want to show more. So we use color and the size of each point to effectively presenting 4-dimensional data on a 2-dimensional plane. And it also have some contour things. In our next homework, we probably will use contour. We're going to use contour things to do things. So this is exactly my process of learning to contour, because I know what I want to achieve. I want to plot the decision bar of decision boundary of the when I train a classifier, I want to plot the decision boundary, and initially I don't know how to do it. I just surfing the web by using Google. Actually, I using Google and find out the Matplotlib page, and finding the example. And after I find the first example, I don't think that is quite the things I want. So I go back to the Matplotlib gallery and just go to the parent web page and find out the related examples in the same page. And finally, I find something I sort of need, not exactly the same, and I do the adjustment here and there, and finally I get something I want. Like something, I mean, whether you want a color bar on the right hand side, whether you need the boundary line to be specifically, I mean a level curve to be plotted, and what kind of color, like this one is using the discrete color, and this one uses the color map that is continuous color map. And maybe sometimes we also want to plot the sample on it. This one is a distinct boundary, but we want to see, okay, how many false positive and how many false negative, and are they very close to the boundary? So we want to plot the samples point as a scatter plot over this contour things or heat map things. There are a lot of details, and you first need to know what you want and ask your question, and you can find it online. But if you don't know how to formalize your questions, you don't even know the terminologies, one way to do that is just browsing through the gallery and see some things resemble what you need. And also they can do the vector field. Here, when I do the diffusion lecture, I have to control something like this one. Maybe before diffusion, by doing the generative flow, we need to kind of have something look like a vector field. I am not that familiar with vector field, especially I can do this one, but the thing is you have to choose the color and the length of the vector. There are a lot of different parameters you need to adjustment, and also I don't think it's in the class, but at some point I need to have this orbit or the trace of this vector field. I have to draw something like this one, and this one is not initially not the things I know how to do that, and I don't even know I can do that right away right now. But the thing is, I don't think that is an issue, because first of all, I know Matplotlib can do that, and second of all, I'm pretty sure I can find some example on the internet, or maybe just in this gallery, to find something I need. If not, then I'm still not in a trouble, because I can read a document and be creative using the functionality to achieve what I really want. There's also some line plot mostly for the time series, things like this one. And this kind of things are curved with arrow bands or arrow bars. Those are arrow bars, but you can also do the arrow bands to not only demonstrate the mean of at each step or each time. You can also show the confidence interval or things like that in each point on the curve. And this one seems to be interesting. It's kind of like the matrix circle things, but I'm not exactly sure they are doing the same. They probably just composite a lot of different. Maybe I'm not sure how it is done, because if you are simply plot a lot of curves together, you probably get something like this one, the first one. But these two are sort of interesting. So sometimes maybe I will check back to this example later, because this one do seems interesting. But I still believe if this is not the same as my approach, I still think my approach is quite okay. And also some ideas, give you some ideas of what kind of graph can it be. Like this one is showing the distribution and all this filing and other different kind of filing plotting and different type of box plotting. Okay, and different kind of pie plotting. People doesn't like pie plotting. A lot of people doesn't. When they see a pie plotting, some people when they see a pie plotting, they automatically think that it is a bad presentation because it is kind of difficult to compare the size of different things. I'm not that against with pie plotting, but it does kind of waste of some dimensions, I believe. So if I have better choice, I probably will choose other type of graph. But still, there are some situations. I mean, this is just one of the traditional. What I say was about the traditional pie graph. There are different type of thing. People are so used to like the different dimension polygon things like that. So those type of polygon, because people are familiar with that, like you see the 六边形 graph, the hexagon graph, things like that. The polygon graph, actually, polygon graph, a polygon diagram. You see a lot of like the language model, official language models. They also show for each dimension. They also show the strength, the result of each, the score it achieved on each dataset, testing dataset. So in a polygon graph, the area of the polygon is a measure of how good this model is. So they have their places, and also this one is an interesting one. It is actually a scatter plot, but using the radius, a radius coordinate, not just the Cartesian coordinate, but they are using radial gradient. So if you can use the more dimension for a pie graph, it kind of using only one dimension. That is the radius part. I mean the because in the radius coordinate, we still have two dimensions, the length and the angle part, the angle part. But it only uses the angle part, so it effectively uses only one dimension. So that is probably the reason that pie graph is not that good. But you can see that in other cases, both of the dimensions are used. So that is probably a good idea to use this kind of things. Okay, let's go to the seaborn and to see the seaborn gallery. Seaborn also has a gallery. It has different part of its functionality, like objects API, relational plots API, distribution plots API. So the relation plots is about if you have two features like X and Y, or maybe like Z, and then you show the relation between them. There are different ways to show that. A lot of time, this is probably the things you want to show. So it already has a lot of different type of relational graph. immediately, that you can use immediately, ready for use. And for the distributional part, it is used to show a distribution. It also has a lot of different type of graph that can help you to show the distribution. It also has categorical plot to show the category, and regression, multiplot is different. Just you can show different plot in the same figure. And it also have some APIs for figure theming and the color palette. But for most of you might want to check this 1, 2, 3, 4 parts if you are trying to show the data or results in data science. Probably this 4, or maybe the first one, is the more useful, and a lot of different type of things you can see. So this one is by showing the relational plot, one of like a scatter plot, but you can see that we can give it dimension. X is the total bill. It is still using the smoker tax total bill, tips total bill things. So we are trying to visualize total bill, tip, smoker in these 3 dimensions. We use 2 dimensions because the major dimension is X and Y. And we still have the other 2 dimensions. One is the hue, is the color. And the other is the style. That is, you can see it's a cross, and this is circle, the dots. So we have these 2 dimensions together, and to combine these 2 together to show the smoker things, to emphasize the difference between smoker. But the thing is, in order to plot this type of thing, you only need to provide what is your X, what is your Y, and what is the third dimension is. And you immediately, automatically get a perfectly fine graph and informative graph to see the relation between the total bill and the tips in different group, the smoker group and the non-smoker group, just in one line. That's all you need. Because we are not a designer or something, we just want to quickly see the graph and answer our questions. So seaborn serves these needs. Another type of is this line plot things. It automatically gives you like the color band around this curve. Because if you are trying to do this in Matplotlib, like this is what I do, you can do that. If you are doing in Matplotlib, what I do is I need to plot one upper bound, like decide what is upper bound and what is a low bound. Maybe it is like the 25 percentile, 75 percentile, or maybe like 1 standard deviation, 2 standard deviation. And I use this to do a fill in. You can fill in the color between these 2 lines. That's what I do. You use one fill in between lines, and I define the upper bound and low bound, and I get the band. And I plot this curve in the middle. That's what I do when I do a Matplotlib. It is a bit tedious and difficult, and you have to compute the standard deviation or things like that by yourself. But the thing is, sometimes I want to do a more difficult, a more interesting plot. I don't want just one band. I want 2 bands. I mean, I'm using one band for the one standard deviation, and a wider bar but lighter, more transparent band for like 2 standard deviation, and another one for 3 standard deviation. So it will look like more colorful, like more intense in the middle, and a little bit lighter on the outer side, and another band is even lighter. It's very visible to indicate the three standard deviation. Or maybe I would just using the intense at each moment, sort of using the normal distribution since not 3-band, just a continuous band, but it's getting lighter and lighter outside. That is sometimes I want to draw things like this to make it the visualization more. I mean, my policy is that the thing is the way that I make the part more intriguing or interesting is to make it contains more informative and people kind of buffering or didn't understand it immediately. Kind of like 不明觉厉. You don't understand what it is, but it looks so advanced or so awesome. That is one of the strategy that I try to make things. But the things behind it, I have some ideas of what I want to achieve. And I have my reason. Because sometimes I think one standard deviation is not enough to show the variance between things. Because one standard deviation is on the up and down, one standard deviation only includes something like 67% of the data. Like 3 standard deviation is more than enough. It is probably more suitable. But if I draw this band using like 3 standard deviation, it will too wide. So if I have like this one, like 3 different curves, they are overlapping too much. It will make the graph very difficult to read. So I made it lighter, much lighter. But if I make it too light, it's still sort of uninteresting or unreadable. So I make it 3 different level of shade, corresponding to 1 standard deviation, 2 standard deviation, and 3 standard deviation, to guide them to see the wider band. But at the first glance, they probably will focus on the 1 standard deviation band. That is good for first impression. But if they want to look closely, they can follow the decreasing intense of the shade and see the wider band, the wider 3 standard deviation band. But they are so light, so they are not overlapping to interface other band. Even if you are getting confusion, because we have it progressively, so you can kind of figure out which band is which. So I am not entirely sure I can do this in seaborn, so I didn't bother to do this in seaborn. I don't mind to write like 5 or 10 more lines to show one graph. And I don't really care about how the theme it used. Sometimes I just use I use like BMH theme, and sometimes I only use the vanilla theme that without anything. That is already good enough for me. But I do really need the freedom of making things. I kind of think maybe seaborn already provides things like that. But the thing is, even if the seaborn satisfy my need when creating that kind of figure, perhaps I change my mind. I want to adjust the things. And sometimes that beyond the capability of seaborn, and I have to write it all over again. So because I usually draw the images in a more unusual way. So that is why I didn't use seaborn. But if that is not your case, you are more like drawing product like this one, or maybe like this one, or like this one. Then seaborn is perfectly fine and perfectly good. I use seaborn sometimes. I just don't explore the details or functionality that much like I do for Matplotlib, because just like I said, I'm more used to do the more fancy or funny things. When I want to do the funny things or fancy things, I will use Matplotlib. But I still use seaborn sometimes for this kind of. What I'm trying to say is, I believe seaborn can do much more than this guy. Like what I did, like 3 band for each curve, I believe it can do that. I have to rephrase myself. I'm not saying I believe if it can do that, it is not surprised. I won't feel very surprised if it can do that. Like it gives some functionality like bands equal to a list of things that give you a choice of standard deviation or median or other things. I think that is totally possible. But the thing is, if you are going to that far, you probably want the freedom of Matplotlib. But on the other hand, if this is exactly what you want, maybe you want to change the color a little bit, change the size of graph, that's fine. If that is pretty much what you want, seaborn is a perfect choice and probably a better choice. And seaborn already have a lot of freedom. Like we probably mentioned before, if a lot of people want it, they are probably give a request to the seaborn developer team. And if really a lot of people ask for it, they probably will implement into the seaborn library. So you probably can already find most of the popular layout or graph styles in the seaborn already. So this is something probably a little bit difficult to do in Matplotlib, because you probably have handled these things by yourself. If you already have this curve, this is just filling between the curve and the x-axis. Matplotlib has this functionality, but this is done by doing something like histogram, and it uses KDE. I probably demonstrated it in the pandas things, like using KDE things, but doing for 2D, it's more advanced than this one. But you can see that it requires some coding, manually coding things. If you don't care about, anything is fine, KDE or other density estimation method, just give me one. I just want to see something. I don't care which one you use, just give me some estimation. And then you can use that. And if you see the document, maybe you can choose different estimation easily, because they have already written the code for you. So like Matplotlib, it has a gallery you can choose from. It is just a simple glance of what has been provided in the gallery. It has a lot of different things. Not that much different than Matplotlib. But probably you can use less code for writing a graph using seaborn. So if this is the variety in this category is good for you, then you probably seaborn will be your best friend. Okay, so seaborn is built up on Matplotlib, so it can be considered as a higher interface high-level interface of Matplotlib. So although I am saying that I use Matplotlib, doesn't use seaborn, but I don't think seaborn is so lot different than Matplotlib, and you can actually combine them together. But I mean, it's kind of like the SciPy and NumPy. Although they are different, they are different libraries, but sometimes we use them exchangeably. I mean, sometimes we refer SciPy as NumPy because it is so close to NumPy, although they are different library. Those are kind of like seaborn and Matplotlib. But there are more than just Matplotlib in the world. There are other libraries. One of them is Plotly. Plotly can be considered as seaborn plus Matplotlib because it has a higher level UI API and a low level API. But more. The major difference between Plotly and Matplotlib plus seaborn together is the interactive part of Plotly is mostly focusing on web user interface. So Plotly is more like a Matplotlib, but on web user interface instead of like a native UI window things. Because Matplotlib originally is just the interactive backend is just a X11 window app, but Plotly is more focusing on web interface. It is more commercial oriented, although Plotly is perfectly free and open source. But the developer behind it is a company, a commercial company. So it provides commercial service, and some of them are some of the extension, or like I think it has a Plotly Studio or things like that, a software that you can design a Plotly graph using a more no code or like user interface things. Like what you see is what you get things. Of course, they also have provide some customer service, and some libraries are more. You need like a DLC. It's a free game, but has a DLC. Sort of like this kind of things. And if you are paying customer, you are getting a better service. But you can using it freely, just like Matplotlib or seaborn. Just remind you that some of the things you see on its web page, you need to pay for it. It's not like it is trying to accidentally scam you to pay things. It's not like that. But just because it is commercial, it is a company, it is a business. So it will have some like advertisement or commercial things stuff around it to promote their product in a not like a pop-up or something like that. It just will introduce a lot of functionalities, and also they will provide some integration of their service, something like that. We'll show their website a little bit later. Okay, I didn't put a link right here. But you can see that it's data apps for production. So another product of Plotly is Dash, which I use a lot. It is used for creating a web app, a web application, mostly focusing on data science and the plotting things, because the Plotly is their flagship product. So the dash can show a lot of data, but it is used for creating a web application. So you can see that it's data apps for production. So unlike Matplotlib, they are more focusing on, or their goal is, at least their goal is to build a product that people can actually use to build their product, actual product, commercial product. Okay, so this is how the code is write. The high-level library is called the Plotly Express. It's sort of like seaborn, except it is interactive defaultly. The only graph it can show is interactive graph. Otherwise, you have to explore it. So I'm not be able to only show you the screenshot, because the part is you can do something like this one to do interactive thing, like hover over it and choose a part. It also has a bar, a toolbar that you can customize it with it. It is not the most customizable thing. I mean, you cannot just replace this bar into a file menu or like a menu or like other things, but it is customizable for sure. So this is basic part, and this is another one, and by default it is interactively. Even if you're showing it in the Jupyter Notebook or Visual Studio Code, it is things like that. Imagine you can add this interactive graph into your web application, or maybe in your mobile applications. That would be pretty good. So you can see this beautiful and very fancy interactive functionalities. You can actually take a screenshot of things to download the JPEG and do the box select things. A lot of different things you can do that. And zoom in and zoom out. So the architecture is more complicated because it has a JavaScript side and a Python side. So makes things more difficult, different than the Matplotlib. It also has some galleries right here. You can see a lot of different like line charts, scatter plots. Already you can see the style difference between the seaborn and the Plotly style. I won't say it's more modern, but it is different. It is different. I don't think the seaborn style is outdated, but it's maybe something that you will see more recently in this kind of style. It also, because it is production oriented, so you can see that it is easily integrated with like geographic things. Like we said that we can use a map image as a background if we when we want to use our like a plot with geographic informations. But you have to handle the map by yourself. In the Plotly, it is already integrated. Like what we do in Pandas, we were showing the map. it is already integrated with it. You don't have to download the map yourself. It is calling the API and downloading the data for you automatically. And here is another section of the Plotly. Because like we said, we are talking about graphing or plotting, but different area have different tests. So one of the area is the scientific community, and very close related is the data community. And also in the field of financial, they are also using graph a lot, like pie chart. If you see a pie chart, you probably will think about a company or demonstrate things, or a trending chart or things. So a lot of different area using the chart in a more different way. So, and they have different convention and different preference. Here it has a section for scientific plotting. So it actually shows they care about scientists or data scientists or data engineers. So they care about. They are also a part of galleries about the financial graph, and a section about statistics graphs. So here, I think it's more like statistics things. You can see that this is more about statistics, like the arrow band we were talking about here, and the strip chart. Okay, this also shows the marginal distributions here. Like a histogram with the marginal histogram, and the histogram with different styles, box plot, of course. This one's arrow bar, this one's arrow band, and the filing plot. All of these things, they are probably the statistics scientists, but especially the statistics part or data part, who are more care about this. These are the graphs that statisticians or data scientists are more familiar or care about. So they provide all this kind of graph already. And also, these are the graphs that scientists like the physics, scientists in chemistry, chemists and physicists, like a vector field, or like it's called capit plot, to a wireframe of a manifold or of a surface, or like a network graph. I think data scientists also like network graphs, but here we go. The physics also like it, or the chemistries also like it, and like this is not something I didn't use. This dendrogram, annotated heat maps, or all these things that people familiar in certain field. Personally, I don't even know what this is doing. I seldom see this one, and I don't even know this one called the carpet plot before. But certainly, definitely, this is something people use in certain fields. And also in AI fields, we care about the classification boundary and the PROC curves, visualization by using PCA, or doing the annotations like AI ML applications. It also target this kind of audience. So partly their goal is to be a general plotting application infrastructure, especially for building product-ready things. And by these examples, they are claiming that they care about every audience. They are caring about a wide range of audience, like AI scientists, data scientists, statisticians, financial. I didn't show that because I'm thinking we don't have many financial parts, but there is a section for financial part, and of course the physicists, the chemists, and more. So that's probably a quite variety and wide range of audience. And Party Express is its higher level UI. It can already show a lot of things, including 3-dimensional graph and images and animations. I didn't show right here, and the polar coordinate things. Okay, another thing is the Dash, one of their product. I think it's very useful for people like data scientists, because it can help you to quickly build an app for your models or data. I will give you a quick overview of this. So this is its application already. By writing this short kind of code, this is already you can write this application to demonstrate your models or other things. You can have a lot of different interactions. Unlike Matplotlib, these interactions are actually more modern and has more widgets. Like you can see, this is a selection. We have a selector here. And it also has buttons and other things like that. And they care about AI and the data scientists because this is a hardware area. So it has some functionality of building like annotations. This one is a bounding box things. So you can interact with it more easily. Although I say that I mentioned that you can do that in Matplotlib, but you have to write your own handler. This has been already done for the Dash apps already. And it can do more than box, bounding box annotation. It can do segmentation and all other like polygon things, all other things. I'm not saying it is perfect. I still think it is still behind the like Label Me or Label Studio things. But it's kind of work, and I'm using it in some demos already, and get a pretty good reaction. So you can consider it as a solution. Okay, so and also it can help you to build modern applications because it has a community plugin called the Bootstrap. Although it is a community contribute extension, it is mentioned and you can consider almost like a official module of it. So Bootstrap is a library used a lot, a framework that used a lot for people, especially for back-end developer, because we don't know how to build a perfect front end. But by using Bootstrap, it provides a lot of different components, like buttons, and it has a possible style choice, like this kind of modern colors themes, like a nav bar and things. So you can build an application really quickly without knowing the front end things. You still need to know a little bit about something like layout things. You still need to learn some things, but it is much easier if the alternative is you to learn the full developing process, like learning a few, like React, Angular things. It is much easier than that. Even though that like the Vue is some library like Vue is pretty easy to learn. Still, by using these component things, it is much easier. So it can use modern UI component in Bootstrap with your Dash applications. And because the choice of the theme is quite modern and elegant, you don't need to worry about the styling things. It is not perfect website, but it will not be as ugly as you will do by your hand. I mean, if you do a vanilla HTML things, or even if you use a designer to put a button things, you probably will have a wrong choice of the theme or color palette. But using Bootstrap, using a standard way, you get okay things. Myself, I use Dash Mentai because it has a lot of different components. Personally, I think Mentai is a more modern theme. The style of Mentai is a little bit more modern than Bootstrap to my taste. But it is not the reason I choose Mentai more than Bootstrap. It is because it has a very rich component library. So I can build my application really quick with more kind of fancy control widgets with it. Because we don't have enough time, maybe in the afternoon, the Chinese session, I will mention it a little bit more because I can speak Chinese much more faster than in English. So I can cover the content, same content or more content in shorter time. But anyway, you can check this out and find the interesting component inside. Another extension I use is Dash extensions. It's called Dash extensions. It has a various independent, unrelated component. The things I'm using is event source, event listener, event source, Mermaid, and Lottie, WebSocket. The event source and the WebSocket provide a way that you communicate to the server. That is your Python program and the interface together so that you can push some things from, most of the time a web UI is every action is initiated by the user when they click some button, when they input some text, when they do something, and like a mouse click something, and the server receives it and do something. But sometimes you want to update it. You can do it like every 10 seconds. That's also doable. But sometimes you want to initiate the change by the server. Then you can use event source or WebSocket. And Mermaid gives you a pretty good diagram. And Lottie gives you some fancy animation component. It has a large community component provided. And finally, as an ending, also introduce a bokeh. Bokeh is another library. It's kind of like between the Matplotlib and Matplotlib. It also provides some interactive web graph, and it can also provide a standalone kind of like a web page for your interactive things. So it serves perfectly with the binder we mentioned before. But nowadays I didn't use it a lot because it is I use Matplotlib instead. That's my choice. I probably miss a lot of recent advance of bokeh. But my impression is it is more limited functionality. It has more limited functionality. It is good for one-shot demonstration. Like if you only want to have a one-page application and it's just one page, not just you can change your page into another functionality, a different panel, different things, a different tab, different things. Just one page, like this one. If this is all you need, then bokeh is probably easier to do than Matplotlib Dash. But I guess Matplotlib can serve something similar. I'm not sure because I use Matplotlib Dash more. Okay, so that's another choice, alternative choice that you may consider. It may suit for you. It's just I don't use it. But the thing is, the final word is all this library is a lot. People paid a lot of effort to develop this library. They are not easy to develop. Even though I didn't use bokeh, I admire their achievement here. So all you need to do, because people already do the hard work, all you need to do is to learn them. So I provide 3 steps that will help you to learn each of the library. Not just only one library. You can learn bokeh, Matplotlib, seaborn, Matplotlib, and maybe something newer like ggplot or things like other library. First, you learn the basic examples by doing it like a beginner. And second, you have to understand the fundamental component of it. And third, after you know it, you can learn by advanced example, one by one. Because you already know the fundamental, you're not just copy the code, you understand what's happening. And you can, because you know what's happening, you can change and adjust the code by your need. Okay, so that's all for today's lecture. So next week, we are going to talk more about machine learning things.